Hello, welcome to this week's My Wisconsin Standards for Mathematics as we take a close look at the use of ratios. There's a progression of ratios in the Wisconsin State Math Standards that begin with 6th grade and go all the way through high school. In 6th grade, students begin to understand the concept of a ratio and use ratio language to describe relationships between two quantities. In 7th grade, students begin to look at proportional relationships between quantities and solve multi-step ratio and percent problems. Beginning in 8th grade, students look at the proportionality relationship between lines and linear equations. And then in high school geometry, students look at similar figures and also look at similar figures, in particular similar right triangles, when using trig ratios. A ratio describes or shows how two quantities are related. We have an example of Joseph, who enjoys coffee, and in his coffee he likes 1 serving of cream for every 2 cubes of sugar. In 1 cup of coffee, this ratio is 1 to 2. In 2 cups of coffee, this ratio is 2 to 4. In 3 cups of coffee, this ratio is 3 to 6. And in 4 cups of coffee, this ratio would be 4 to 8. The numbers may change, but the relationship of 1 part cream to 2 parts of sugar remains constant. This can be written as 1 to 2, 1:2, or as a fraction 1/2. Next, we'll look at ratios in the geometry of lines. Here we have a right triangle whose legs measure 2 and 3 units respectively. The legs of the right triangle form the right angle. In this situation, the ratio of the short leg to the long leg is 2 to 3, or as a fraction 2/3. Are there other right triangles that are different sizes but have the same ratio? The answer to that is yes. The following triangles all have a ratio of 2/3. However, the sizes of the triangles are different. In one triangle, similar to the one that we looked at in the previous slide, it's 2 to 3. In the other triangle, the next larger one, it's 4 to 6, and in the largest one, it's 6 to 9. Again, those triangles have different sizes, however, their ratios are still 2 to 3. Right triangles whose legs have the same ratio can be used to draw straight lines. Here we're going to use our 2-3 triangle and our 4-6 triangle. We're going to use these two triangles to draw a straight line. We can line the triangles up this manner, and we'll see that their slant side, sometimes called the hypotenuse, lines up and forms a straight line. We can give this line a single number attribute, which we call the slope. In this case, the slope is 8 over 12, or 2/3, the same as the ratio of the leg. Another way of using ratios occurs in geometry, namely trigonometric ratios. Trigonometric ratios are ways of comparing the lengths of the sides of a right triangle to one another. In a right triangle, we have 3 sides. There are 2 legs that form the right angle, and the hypotenuse, which is the length of the longer side. The ratios, or comparisons of those lengths, are done using trig ratios, or sine, cosine, and tangent. Sine is the ratio of the length of the side opposite of an angle to the length of the hypotenuse. Cosine is the length of the leg adjacent to the angle compared to the length of the hypotenuse, and tangent is the length of the leg opposite of the angle to the length of the leg adjacent to the angle. In this particular example, we have a triangle that's a 3, 4, 5 triangle. The 2 legs are length 3 and 4, and the length of the hypotenuse is 5. In this case, the sine of this angle would be 3/5. The cosine of angle A would be 4/5, and the tangent of angle A would be 3/4. For more information, or if you'd like to have a deeper conversation about the progression of ratios as they are outlined in the Wisconsin State Mathematics Standards, please visit us at our webpage.